Hi friends, this is Sri Ramulu. So today's topic is Gauss law, right? So Gauss law in electrostatics. And before this watching this video, please subscribe it. Don't forget. And one thing, so you must subscribe while you are watching this video. Why? Because I am um, for you this information I am struggling for collecting this information. So for this purpose only, please subscribe this video, right friends. And now the Gauss statement is there, Gauss law statement. So what is the statement of the Gauss law? See here, the total electric flux pi e over a closed surface is 1 by epsilon naught times the total charge q enclosed within the surface. See here, so over a closed surface, how much flux present, so flux must be total charge. If you multiply 1 by epsilon naught to the total charge, how much value you get, that much of flux present in the closed surface. That is the meaning of this, right? And the next, mathematical expression. So mathematically it can be expressed as pi e integral e bar dot ds bar is equals to eds cos theta. So I think everybody know about the dot product between the two vector is it is can be written as a dot b is equals to a bar dot b bar is equals to ab cos theta. For dot product it is theta cos theta. For cross product, a bar cross b bar can be written as ab cos ab sin theta into n cap. So n cap is a normal vector, normal unit vector it is, okay. And here epsilon naught is what? It is a permittivity of free space. Means what is the meaning of permittivity? So free space, how much fluxes it is permitting through it, how much fluxes permitting through it. So that is that will be indicated by the epsilon naught. So that is why epsilon naught is called permittivity of free space. So how much fluxes it is permitting, allowing. Next, and the Gauss law can be available in two forms. So one of them is a integral form of Gauss law. So how can we calculate integral form of Gauss law? So there is a proof for this. So when the charge is within the surface, so Gauss law can be proved when the charge present within the surface. See, it is a surface. When the charge present inside this surface, that means at what point? At this point, right? At this point it is presenting. Now let us consider plus q be the charge it is, okay. Plus q be placed at O point. So plus q charge is placed at what point? At a O point within a closed surface of irregular shape as shown in figure. So shape is not important, but that shape must be a closed surface. That must be a closed means it cannot be like this, okay. That must be a closed one. Either whatever shape it present, any shape allowed, but that must be closed surface. Next, consider a point P on the surface at a distance r from O. So consider one point. So let that point is at this place, okay, at the point P. And at what distance it is? At r distance from O. From this point to here, how much distance present? R distance present. Now take a small area ds around P. So small area, take a small area ds. So it is a point P. Around this P take a small area, and whose area element is ds, okay. Area is ds. Next, the normal to the surface ds is represented by a vector ds bar. It is generally it is we have to write it as a ds bar vector. Why it is a vector? For vector we denote it ds bar. So here you write it ds bar, okay. It is a ds bar. which makes an angle theta with the direction of the electric field along OP, right? So this makes, which makes ds makes what, theta angle with E is always outwards only. Already we know the plus charges having the outward electric field, electric lines of forces, and minus charges are having inward electric lines of forces, right? The electric flux phi E outward through the area ds is given by dA. Here which area we are considering, very small area, then how much fluxes passes through this area, very small amount of fluxes passes, so very small can be denoted by d phi E. If you write a d, it indicates the small fluxes, small number of flux. So when we get small number of flux, when there is a small area, right? When the small area present, then only small number of fluxes present. If you want to get the total number of fluxes, then you must integrate it. Next, and E dot, if you remove the dot product, then we can write it as a EDS cos theta, right? Already I told you EDS cos theta. So for dot product cos theta, where theta is the angle between E and ds. Yes, from the Coulomb's law, the electric intensity means electric field E at a point P at a distance or from a point charge Q is given by. So what we are applying, we are going to apply Coulomb law. So right, Coulomb's law, it is Coulomb law, equation 2, it is a Coulomb's law, okay, at a distance r. So in a E is equals to 1 by 4 pi epsilon naught Q by r square. It is equation 1, equation 2 it is, right? So equation 2 is Coulomb's law, and equation 1 is what? Equation 1 is pi is equals to EDS cos theta. So in the place of E, what we have, we must substitute this E value, this E term in the place of E we have to substitute. So here, okay, where we substituted, once again see, this E term is substituted in the equation 1. In the equation 1, what is in the equation 1? There is a E term, in the place of E we have substituted what? This is total. Okay, see, in the place of E, E is what? Q by 4 pi epsilon naught into r square, and already side is there ds cos theta side. Okay, so it is clear. Once again see it. Okay, now, and here what I am writing, simply r square, write under this quantity, then so this quantity replaced, but ds cos theta by r square is a solid angle, it is denoted by d omega, subtended by ds at O. Hence at O means here, so if you see the diagram, so point is here, and we have drawn like this and like this, so it is like a cone, and it makes angle here. What makes angle? That angle is called solid angle, it is denoted by d omega. See in the diagram, see, it is like a cone. Okay, so like a cone, so here angle what present, that angle is called d omega, right? Clear? Now see, so in the place of ds cos theta omega, cos theta by r square, it is replaced by what? D omega. So from the above equation, see, so in the place of this, what is substituted? D omega is substituted. Now total flux, if you have to know the total flux, then you have to do what you have to do, you must integrate on both sides. So integrating on both sides, so if you integrate this side, so then also this side, so integration for differentiation gets cancelled, you get only this one, and this side integration present, that integration is here, these quantities are constant, that is why integration is attached to what? D omega only. Okay, so that is why integration is attached to the d omega, and integration of d omega formula is its value is 4 pi. So in the place of d omega, what is substituted? 4 pi. This 4 pi gets cancelled, then finally what we got? We got q is equals to, sorry, pi E is equals to q by epsilon naught. So this is the general form of what? General form of Gauss law. Now integral form. Now substitute this already pi E is equals to q by epsilon naught into, already we know the pi E term is what? Integration what? E bar dot ds bar. So pi value what we got? We got it is as a q by epsilon naught is equals to integration E bar dot ds bar. So this is the integral form of Gauss law, q by epsilon naught. All right, so this is the integral form. And next, differential form. So according to Gauss law, what is integral form? This is integral form. And from this, bring this epsilon naught this side, it comes this side. So then we write epsilon naught integral e bar dot ds bar is equals to q. Okay, let a charge q be distributed uniformly over a volume v and rho be the volume density of the charge, then volume density, then we write q is equals to what? How can we write? Generally rho formula is what? Q by v, right? Q by v. So for the small volume, small charges will present. So that means within the small volume only dq by dv present. In the small volume, how many number of charges present? Very small number of charges present. So like this. And right here what? So bring this dv this side, rho dv can be written as dq, right? From this dv is brought this side. When you bring this side, then rho, it is a dv already, it is rho dv is equals to dq. So dq, integrating on both sides, integrating. So how many times you have to integrate? It is a volume. In volume, how many quantities present? Length, breadth and height, 3 quantities present. So that is why how many integration we have to take? 3 integration. So this side single integration enough. For single integration, differentiation is cancelled. So that is why q is equals to triple integral rho dv. This is the formula. So we got like this, we got this equation. Okay, now let it is equation 2. Now see here, this q term is substituted in the equation 1. Okay, so what is here? Q, you have this q substituted here, then what we got? This we for third equation we got. So epsilon, third equation is what? Epsilon naught integral e bar dot ds bar is equals to triple integral rho dv. Triple integral indicates volume, double integral indicates area, single integral indicates length or breadth or height, whatever it is. Okay, single term. Next, now we use divergence theorem. So which divergence theorem? Gauss divergence theorem is there in vector quantity. Okay, so this that Gauss divergence theorems, what it will do? It converts a single integral into triple integral, right? It converts single integral into triple integral. So see here, now we use Gauss we use the divergence theorem to convert the one integral or single integral into triple integral. That is, now see here, so e bar dot ds bar, it is a single integral, can be written as in terms of triple integral divergence e dv. It is a formula, divergence e dv. But general formula is what, you know? For example, it is a is a vector quantity, a bar dot ds bar can be written as what? Triple integral divergence a dv, right? A dv. In the place of a, what you have here? You have e. So here a, here a, then in the place of a, if you substitute e here, then here also e comes. So that is why e here we got. Substituting the e, let it is equation 4. Substitute equation 4 in equation 3, where or apply. See here, this is the equation written dive. So see here, so in the place here already what we have, so this is, so apply this one here, then what? Triple integral dive. So this side whatever things present, this and this both are same. So when you apply the epsilon naught, then when these two sides are equal, then these two sides are also equal. So that means we write it like this. So what we have to do to make this is equal? See here, here you have multiplication epsilon naught. So both sides multiply epsilon naught, this side epsilon naught and this side epsilon naught. So I have forgotten to write this one, sorry for this. So multiply on both sides epsilon naught. Now see, so this is equal to this. both are same, then this is and this are equal. So with here epsilon naught div e dv, here is also same, epsilon naught div e dv is equals to rho triple integral rho dv, right? So friends, what I forgot in here, one thing, to multiply epsilon naught on either side of the equation 4, then only equation 4 and 3 are same, right? Or substitute this term here, okay? So then only equal there, when you substitute in the place of this, then this equation will come, okay? And write it is a inside, then this is triple integral volume. What are the difference? In the place of rho, what you have? In the place of rho we have epsilon naught div e, so we write rho is equals to epsilon naught div e, or epsilon naught div e is equals to, we write rho. Now see next to it is epsilon naught div e is equals to rho, okay? So from this bring this e naught this side, so it is multiplying this side, and then this side what it will do, it divides. And a divergence can be written as del dot e, right? Divergence e means it is a del dot e, or divergence a means it is a del dot a means divergence a, that is the meaning of this. So this div can be written as del dot e is equals to rho by epsilon naught, and we know the relation between d and e. So already it is a relation between d and e, so I will do one video on this also next time. Now d is equals to what? Epsilon naught into e is there. From this e is equals to what we can write? So bring this e this side, it becomes d by epsilon naught. So in the place of e, substitute d by epsilon naught, okay? So in the place of e, d by epsilon naught. So then when you substitute like this, these two gets cancelled. Del dot d is equals to rho. It is the del dot d. Del dot d can be written as divergence d. So divergence d is what, you know, it is the, or either this or this is called differential form of Gauss law, right? Differential form of Gauss law is del dot t is equals to rho, or we can write it as div d is equals to rho, okay? And it is defined like this statement, okay? Statement is, this states that the divergence of electric field is proportional to the charge at that point, or flux of E depends on the magnitude of charge or density. See here, flux or E d value depends on what? So charge density depends on charge density, okay? So it is a statement, okay? Thank you friends, this is the video.